video is for the linear transformations foldable. We're going to look at horizontal shifts, so moving left and right, and vertical shifts, moving up and down. And so the rules for those, for a horizontal shift, is f of x minus c, and then a vertical shift is f of x plus d. Okay, so horizontal first. So that's f of x minus c. So what this does is this shifts the graph of the parent function, f of x, left or right. It's just going to scoot it left or right on the graph. So if that c value equals 0, there's no horizontal shift. If the c is less than 0, so we're subtracting a number that's a negative, it's going to shift the graph left. And if c is greater than 0, it's going to shift the graph right. Okay? This affects the y-intercept. That's the biggest change to these graphs of the parent function. So here, this center line here that we have going through the origin, this is our parent function, f of x equals x. So that's our parent function. That's the linear parent function. So what I've done is I've shifted this function this direction. Okay? So I've got to figure out how much I shifted it that direction. So you try to find a nice pretty point. And so we can use the origin here. And then I'm going to use, and so along the x-axis, it shifted to -7. So it shifted 7 to the left, which would be f of x. So if I write this rule, it moves 7 to the left. 7 left. So my rule is f of x minus c, 7 to the left is a -7. So if I plug that value in for c, minus a -7. So remember our rule here, we don't like to subtract a negative. So I would write that as f of x plus 7. Okay? Because minus a negative turns into addition. So that's my transformation. So my new function has a different name now since we transformed it. It's now going to be g of x. And the equation, instead of x, that's the equation of this line. The equation of this line is going to be x plus 7. So the c value is a -7, and it's a left shift. So I know this is a lot of information, okay? But there's rules, and we always follow the rules, and those are what will keep you safe and help you with this. So our original function here is this parent function f of x equals x. Okay, that line again that goes to the origin. And so this time we shifted this line to the right. So again, our parent function is f of x equals x. And so this time I shifted again. If I find the points on the x, I went from 0 to 7. So I shifted it right 7. So my transformation would be f of x minus 7. Okay, I know that's hard for your brain to process, that we moved -7 this one and we're adding a 7, and that we're adding 7 to this one and we're subtracting it here. So that makes my new function, my transform function, g of x equals x minus 7. So the c value is 7, and it's a right shift. Okay, so here we go. We're not starting with the parent functions. We are starting with other functions, and we are using these rules to translate them. So it says write the translated functions. We're going to do f of x equals 12x plus 3, and that's going to shift 2 units to the left. So my rule here, to the left, okay, is going to look like this. F of x plus however many I shift. So f of x plus 2, okay, that's a shift to the left, equals, okay, 12. So I'm going to plug this in for this x. I'm going to swap out that x with my new value here. and then I'm going to simplify. So I'm going to distribute first. So I have 12x plus 24 plus 3. Sorry, and so that new function again is g of x. And then now I can combine 24 and 23. G of x equals 12x plus 27. So if I take this function, I shift it 2 units to the left, this is going to be my new equation, my new function. And you can tell the only thing that changed here was the y-intercept. All right, now I have f of x equals 8 minus 6, or 8x minus 6. We're going to shift this 7 units to the left, or to the right, sorry. So to the right, we're going to subtract that number. So I'm going to do f of x minus 7. So what that means is this x is going to flip out with that transformation. And then I can simplify. So my new function name is going to be g of x. 8 times x is 8x. 8 times a negative 7 is a negative 56. And then this minus 6 at the end. Combine those like terms. Negative 56 minus 6 is minus 62. Okay, so those are transformations of functions. All right, so the next ones we're going to look at are the vertical shifts. So now we're shifting up and down. So the rule for this one is f of x plus d. So these work a little bit different. We don't plug them in the same way, but let's just start with what they look like. So this is going to shift the graph of the parent function f of x up or down. So if that d value equals 0, there's no vertical shift. If d is less than 0, it's going to shift the graph down. And if d is greater than 0, it's going to shift the graph up. This affects, again, the y-intercept. It's not going to change the slope of these linear functions. Okay, so our parent function is this line here that goes to the origin. This is f of x equals x. So anytime you see a line, and this is the equation, y equals x, that's the parent function. That's where you're starting from. So this time we're shifting up. So I'm going to see how far it shifted up. It went from 0 to positive 9. So we shifted up. So my parent function is f of x equals x. If I shift it up, I'm going to add that number. So the rule would be f of x plus 9. So my equation would be g of x equals x plus 9. That's the equation of this new line. So d equals 9, and it's an upshift. All right, here again is f of x equals x. That's my parent function. I'm going to compare the y-intercepts. I went from 0 to negative 9. So that's my d value, is negative 9. My parent function is f of x equals x. So my transformation would be f of x minus 9. And so that would turn into g of x equals x minus 9. And that's a downshift. All right, so same thing here. We're going to write these translated functions. So I'm going to take f of x equals negative 7x minus 4, and I'm going to shift it 5 units down. So 5 units down looks like this. So f of x, and then I'm going to subtract 5. So what that looks like in the equation is just I write the original equation of the line, and then I'm just going to subtract 5 from it. So if the rule is inside the parentheses, you swap that rule out for x. If the rule is outside the parentheses, you just tack it on to the end. So for this one, all I have to do is combine like terms. Negative 4 minus 5 is a negative 9. That's the new function. All right, f of x equals 11x plus 10. We're going to shift this 3 units up. So f of x, we're going to add 3. So I would take this original equation, this original function, and just tack on plus 3 to the end. So my new function, my transformed function, would be 11x. 10 plus 3 is 13. So 2 different ways to work the rules. It's just one of those things that you're going to have to memorize.